All right, so I'm hoping that everybody has their scatter plot. I'm going to run through the directions real quick in case you are struggling with doing that. So to make your scatter plot, you start off with stat, edit. I still have stuff in here from yesterday, so I need to clear that out first. So I'm going to go up. I highlight the name of the list, and I hit clear and enter. That wipes the whole thing. Then I arrow over to list 2. I go up until it's on top of L2, clear, and enter. And it erases the whole thing for me. Now I'm going to enter that data. So 0, 1, 2, 3, 4, 5, 6, and 7 rubber bands. Arrow over to list 2. And I'm entering the distance traveled in inches. Guys, we're making scatter plots of the data that is on page 3. No, 5, sorry, page 5. So 12, 14, 17, 18, 22, 23, 26, and 30. Make sure you hit enter. There needs to be the same number of X's as there are of the Y's. That's going to be your first step in making a scatter plot. Enter the X's in list 1, enter the Y's in list 2. So stat, edit, and then you enter those values. The way you get it to make a scatter plot, you're going to push second and Y equals. Do you guys see how right above Y equals it says stat plot in blue? You're going to push the blue second key and then that button so that it shows you all of the stat plots. Make sure it's turned on. I'm going to enter in here. If it's not on, you hit enter when it's flashing on so that that's the only piece that has any dark around it. And then this one right here, yours might be showing up in 2 lines, but you want the very first one. The very first one is your scatter plot. Once you make sure that this part is set up correctly, make sure that your X list is list 1, your Y list is list 2. If that ever changes, raise your hand and I'll show you how to fix that. And then to make it show you the graph, you're going to hit zoom right here up by the screen in the very center and option 9 for zoom stat. So I'm just going to hit 9. And this is what your scatter plot should look like. You want to sketch that in that open space, sketch it closer to the left. What do you have to make sure to have on a graph? Labels. Label the x-axis. What should you label the x-axis? Number of rubber bands. What should you label the y-axis? Distance traveled, and you should have some little tick marks there. For 0, 1, 2, 3, 4, 5, 6, 7. Off to the side. Ballpark about where those are. Because of the placement of those dots, you should be able to talk like approximately what are those values on the y-axis. So you need labels, both with words and with numbers on both of your axes. All right. For this next part, and I promise I will write directions for this, we're going to make these calculators find the R value for us. This is the correlation. We'll talk about what R means here in a minute. We're going to talk through how to get the calculator to do it. First thing you need to do is we have to turn on the ability for the calculator to do this. This is a one-time thing unless you reset your calculator. If you reset the memory in the calculator, you'll have to walk through this process again. So push second and 0. Second and 0. Should look something like this on your screen. We're going to go down to where it says diagnostic, which if you can see, this is all in alphabetical order. To get down to the D's, you're going to have to scroll for a while. We can jump there faster. To jump there, hit X to the -1. That'll jump you right to the D section. We're going to scroll down until you see diagnostic. We're going to turn it on. So here where it says diagnostic on, hit enter. This is what you should see on your screen. It's not done yet. You actually have to hit enter again, and it'll say done. It hasn't been turned on until you see done on the screen. Does anybody need me to go through those directions again to turn your diagnostic on? Because if you don't have the diagnostic on, the calculator will not find the R value for you. Yes? Yep. So second and 0 takes you to the catalog. Hit X to the -1. That'll jump you right to the D's, so you don't have to scroll so far. Scroll down until you see diagnostic on. Right here. Hit enter. And then hit enter again. It's not done until it says done. Has everybody got their diagnostic turned on? Like I said, unless you reset the calculator, you're never going to have to do that again. If you have to clear the memory on the calculator, you have to go through that whole process again to turn this on. R value. Go to stat. Push the stat button. Nope, just stat. We're going to go over to calc. And you want option number 8, where it says linreg, a plus bx. Option number 8. So I'm going to push 8. I don't think yours has these prompts, right? Yeah, that's because mine is whatever. Hit enter. This is what it should show on your screen. Does anybody need help getting there? So stat, arrow over to calc, option number 8, make sure you hit enter. For the most part on these graphing calculators, if you know you've gone through all the right steps and it's still not showing you the right thing, you probably just need to hit enter again. You have to hit enter after almost everything on these calculators. Does everybody see this on their screen? The R value is this piece right here. Go ahead and write it down. Let's take it out to 4 decimal places, so 0.9923. 0.9923, or 24, whatever. So our correlation here this piece. Right. So what does number 3 say? What does number 3 say on your page? How safe would Barbie's bunch, like, basically, do you think we could do a reasonably good job of guessing how many rubber bands we would need so that she doesn't bash her head using this data? Yes. So do you think she would be safe or in horrible peril? She's going to be pretty safe. I think she would be pretty safe using this. My justification for that goes back to my R value back here. The closer this R value is to 1, or if it has a negative slope, -1, that means it's a very, very linear pattern. If R equals 1, then those dots are in a perfect line. You could grab a straight edge and draw a line right through them. If R is equal to -1, same thing. Everything would be all lined up. Perfect straight line, just with a negative slope. So the closer your R value is to 1 or to -1, the closer our data matches a linear pattern, and we can use it successfully for predictions then. So very safe, because R is very close to 1. Yep. One group snuck some extra rubber bands in to collect more data. We're going to add a point to our scatter plot. So I want you to go back to your graphing calculator. Go back to Stat. We're going to go to Edit. And we're going to add a value at the bottom of the X list and the bottom of the Y list. How many rubber bands did they sneak in? 15. Does that go in my X list or my Y list? X list. So I'm going to add 15 here. And how far did their Barbie travel with 15 rubber bands? 49 inches. So I'm going to come over here to my Y list and I'm going to add 49 inches to my Y list and hit enter. Let's go look at that scatter plot now. We already told it to turn the scatter plot on, so all I need to do at this point is hit zoom and 9, and it'll show me this new scatter plot. Zoom 9. There's our new point. Way out here. I want you to add that to your sketch at the beginning. That's why I asked you to leave some room off to the right. Add that new point to your scatter plot. 15 rubber bands, 49 inches. Do you think that that point strengthens or weakens this linear relationship? Does it make it look more like a line or about the same, or does it make it look less like a line, more scattered? About the same? Let's check it out. Let's check that R value. Do you guys remember how we got the R value? If it's closer to 1, then it strengthened it. If it's closer to 0, then it weakened it. How do I get to the R value again? Stat. Over to Calc. And option number 8. Option number 8. What's our R value now? 0.99799 or 0.998, right? Yours is exactly the same. Did you add the value? All right, let me check it out. Yeah, you have to press enter again. Yeah. When in doubt, hit enter. If there's nothing more for it to calculate and you hit enter, it won't do anything. Yep. Yes, I do. So did that new point strengthen or weaken our relationship? Strengthened it. We got closer to 1. It strengthened it. The R value is even closer to 1. Our R was 0.998. Do you guys remember yesterday when we talked about Duffs and describing those linear relationships? What did the U in Duffs stand for? Hold on, let's run through it again. What was D? Direction. What was U? Unusual features. What was F? Form. What was S? Strength. Okay, so let's practice using that here. Direction, positive, negative, or none? Positive. If it's got a positive slope, it's a positive relationship. If it has a negative slope, it's a negative relationship. So positive. Form. Does it look linear or does it look like a parabola? Linear. How would you describe the strength? I would say this is very strong. We can use our R value now as a guide as we talk about strength. Closer to 1 or negative 1. Basically, the closer it is to 0, the weaker it is. The farther away on either side from 0, the stronger it is. So if we get close to -1, it's really strong just with a negative slope. If we get close to +1, it's really strong but with a positive slope. 0 would be it's scattered all over the place. It looks like somebody just threw dots up on the board. All right, so back to the U. What does U stand for again? Unusual features. As you're looking at all of this data, do any of these points stand out? That last one, that one that we added, that would be an unusual point because it is far away from the rest of our group of data over here. Was this unusual point following the same pattern as the other ones? So it's an unusual point, but it strengthened our relationship because it was still in that same pattern. So make yourself a note here. An unusual point in the pattern strengthens our R value. So I'm just going to clarify because we said this out loud, but we didn't write anything down yet. How would you guys describe that relationship again? Strong or weak? Strong. What was the form? Linear. What was the direction? Positive. So I would describe this as a strong, positive, linear relationship. Strong, positive, linear relationship.
You don't have to say anything about the unusual features.
If this was one that I was asking you to analyze for me, and it had that point on there, yes. We added that one on at the end. That wasn't part of our original data. But yeah, if you had a scatter plot that looks like the one on your screen right now, then you would say, it has an unusual point at 15, 49, or 15 rubber bands, 49 inches traveled. One group member accidentally left off a digit. We're going to go back to the scatter plot. So go back to your scatter plot go back to your table, because we're going to add a new point. So stat and edit. What do they want us to add this time? 6 rubber bands and 6 inches. So I need to add another 6 to my X list. Does not have to be in order. We can just add it at the end. Nope. Go ahead and leave it there. And then in my Y list, the distance that goes with this 6, these pieces have to be together. Your ordered pairs have to be together on your scatter plot. Yes. It doesn't have to go from 0 to 15 in numerical order there, but you want to make sure that your ordered pairs match up. So 0 rubber bands with 12 inches. That always needs to stay together no matter where it falls on here. Does that make sense? 6 rubber bands and 6 inches. Don't forget to hit enter. Check out that scatter plot now. How do I get to the scatter plot again? Zoom 9. What do you notice? I would still describe this as a linear relationship. It has 2 unusual features. Does one of those unusual features follow that linear pattern? One of them does. Do both of them follow that linear pattern? No. So here we have one unusual point that is in the pattern, and we have another unusual point that is not in the pattern. Please add this one to your scatter plot that you have. Circle it and call it an unusual feature not in pattern. So add that to your scatter plot.
Started doing
There we go. It had an equation in the y equals menu, so it was graphing that equation and your scatter plot at the same time. If it ever does something weird like that, or if it gives you an error, then check the y equals menu. Yeah, hit y equals and erase anything you see there. Hit y equals and erase anything you see there. Do you remember when we did the polars last year? In dual credit? That's a leftover polar equation that somebody typed in the graphing calculator. All right. Do you think that this unusual point is going to strengthen or weaken our linear pattern? Weaken it. Let's go check out the new R value. How do I make it do that again? Stat, calc, option 8. And then you have to hit enter.
Does this little circle thing affect anything?
Nope.
Okay.
But let's get rid of it.
Because you got rid of
Y equals, cleared out. There you go. All right, who else has weird stuff on their graph?
Not on my graph. I got it on the thing. I don't know. I didn't do nothing wrong.
You just hit it twice. Stat, calc, 8. Now hit enter. All right. Stat, calc, option 8, and then you have to hit enter. What's going on here? Zoom 9. All right. I think I'm gonna have to grab you some new batteries. Give me just a second. What's our R value now? 0.8377. Okay, so the problem is you didn't hit enter before the last time. So we're gonna clear that out. Now do it again. Stat, calc, option 8. You can just hit 8. And then you have to hit enter.
Oh, okay.
There you go.
All right.
All right. Our R value is now 0.8377. Is that closer to 1 or farther away? Farther away. So does that confirm what we suspected? What was our suspicion again? That it was going to weaken our linear relationship. All right. Let's come back over here. There you go. Sorry about that. This would be considered an outlier here. It made it weaker. What was our R value again? I'm sorry, I didn't write it down. 0.8377. Made it weaker because it is not following the linear pattern. You could say the linear pattern of the other points. So if an unusual point in the pattern strengthens my R value, what would I say about an unusual point not in the pattern? Weakens. An unusual point not in the pattern weakens our R value. Unfortunately, one group had measured their lowest point of Barbie's head in inches instead of in centimeters. So they had to go back and convert all of their inches from that original table into centimeters. I want to know how that affects the R value. So let's go, we're going to enter this data in the table at the bottom and make a scatter plot out of that. So go back and clear both of your lists. How do we clear them again? Can somebody walk me through clearing out those lists? Go to the top. Okay, arrow. Stat. Nope. Edit. Scroll up to the top, clear and enter. Do that for any list that you need to clear out. Up to the top, clear and enter. I want you to enter that new data from the table that's down at the bottom of the page. If you're changing the kind of plot or you're not sure it's turned on, that's when you have to do the second y equals and go to stat plot. If we're just making scatter plots over and over and over, we already have it set to scatter plot, we already have turned everything on there, then we can just go look at the new graph. Yep, zoom 9. Sorry, I'm just going to check my numbers real quick. All right. Let's check out our scatter plot. Zoom 9. What do you think? Looks the same as the first one, right? How would I know if it has the same strength as the first one? The R value. How do I get to the R value again? Stat, calc, option 8. And then enter. What's the R value? 0.9923. What was it when we did the original data at the beginning? Same thing. Let me go back and look. 0.99, if I round, that'd be 0.9924, right? Original R value. Is that what it looks like this time? All right. So here I've got both of them up. There's our original one. There's our new one. Or sorry, no, this one is this guy. Here we go, I was on the wrong page. Did changing the units affect the correlation? Did changing the units from inches to centimeters change our R value? No. It didn't change R. Because the relative positions of the points did not change. Basically, we just changed the scale on the y-axis, but we didn't move any of those points. We just renumbered our y-axis. R was equal to 0.9924. Make yourself a big note here. This is important. Changing units does not change R. Changing units will not ever change R. So our big takeaways from today, go ahead and flip it over to the back side. When we're interpreting the R value, R can be a positive number or a negative number. So we're always going to have direction. If you don't have a scatter plot to look at, but you do have an R value, you could still tell me the direction. If R is positive, it has a positive slope. If R is negative, it's got a negative slope. Form. When we're talking R values, it's always linear. Always. Even if you see a scatter plot that makes a U shape, if you're interpreting the R value, it's always telling me how close to a line does it look. That's what R does. Strength. -1, that's a very strong negative. That is a perfect negative correlation. Near -0.5, I would say that that's moderately negative. 0 would be very weak. Moderately positive, 0.5, strong. A perfect positive correlation would be an R value of 1. So if I have something in between 0.5 and 1, if it's closer to 1, I'm going to call it, approximately strong, or, a strong relationship. We're going to stick with these LY words. The closer it is to 0.5, I'm going to call it a moderately strong relationship. If it's on this side, if it's over here, I'm going to call it moderately weak. If it's over here close to 0, I'm just going to straight up say it's a weak relationship. So if it's hovering near 0.5, moderately strong, moderately weak. If it's close to 1, I'm going to call it a strong relationship. If it's close to 0, I'm going to call it a weak. Same thing over here, but negative relationships instead of positives. Properties of R, unusual values in the pattern. If it's in my pattern, it's going to strengthen my R. If it's not in the pattern, it's going to weaken my R. R doesn't have units, and changing units for X or for Y has no effect on the R value whatsoever. This guy right here, correlation and causation. Correlation does not equal causation, no matter how strong that relationship is. To make this point, I've got some stuff that I want to look at with you guys tomorrow, but there's one in particular that I thought was hilarious. I don't have it with me right now. So I have a graph, 100% accurate real-world data. The number of movies Nicolas Cage has starred in different years, and the number of drowning deaths in Wisconsin in those same years. This graph, I'm not kidding you, you make this scatter plot, these things are lining up almost exactly. Does the number of movies that Nicolas Cage starred in have anything at all, any cause relationship at all with how many people drowned in Wisconsin? None. They're very closely correlated. If I plot them, it makes this beautiful linear pattern. They have a correlation. There's a relationship there, but it's not a cause and effect relationship. I don't know why they line up, but because they line up, I can say that there is a relationship here. Over time, that relationship might weaken, but it's still there. Just because two things are correlated, just because you see them and they make a nice, pretty linear pattern, does not indicate that one is causing the other one. How would we determine cause and effect? What do you have to do if you want to determine cause and effect? Does anybody know? Probably didn't learn about it in math class. An experiment. You have to design an experiment to test for cause and effect. Just taking data without it being a controlled experiment and just saying, are these two things related at all? I get no information about cause and effect. This is something that is so important. They're going to hit on. I guarantee you there will be a question about this. And I've had to correct other math teachers on this one. If my R value is a perfect 1, it still does not mean there's a cause and effect. I have to set up an experiment if I'm going to test for that. I want you guys to try to check your understanding down at the bottom. If you guys were going to calculate R by hand, there's the formula. This is why we're having the graphing calculators do it. This is why we're not doing it by hand. Right. Try the check down at the bottom.
Oh.
Real quick before I take questions about that. How would you guys interpret an R value of 0.917? Strong, positive, linear relationship. If the fuel economy was measured in feet per gallon rather than miles per gallon, how would that affect my correlation? It wouldn't, not at all. If we had this point, 4.4 city miles per gallon, or sorry, 14.4, 25.5 highway miles per gallon. So this point right down here. Is that point strengthening or weakening the correlation? Is it in the pattern or not in the pattern? Do you guys think that's in the linear pattern or not in the linear pattern? I would say it's in the linear pattern. My line would go right here. If it was a point over here, I would say that would weaken it. It is overall in that linear pattern.